Good morning, everybody. So today we're going to be solving systems of linear inequalities in two variables by doing this by graphing. Essentially, today's lesson is exactly like yesterday's, but we're doing two lines instead of one. So let's get started. Just to remind you guys, if you want to tell if an ordered pair is a solution, all you have to do is plug it in. So if y is -3, is that less than -3 times -1 plus 1? Well, if you do that, you're going to get -3 is less than a +3 plus 1. So -3 is less than 4, which is true. But remember, you need to check both, and it needs to be true for both inequalities. So you need to check, is -3 less than 2 times -1 plus 2? Well, yes, it is. -3 is less than -2 plus 2, which is 0. Right? This next one, similarly, right, you're going to plug in for y. Is 5 less than 2 minus 1? No, 5 is not less than 1. So it is not a solution, right? You don't even need to check that second one. Right? Okay, so we're going to get into graphing systems of two equations. So what you're going to see is something like this. You're going to have two lines. Excuse me. You're going to have two lines graphed, right? And you're going to have to look for the overlapping shaded region. This is where your solutions will fall. It can't just be in one or the other. It has to be true for both, which means it has to be in a region that is shaded for both lines. So once again, the solutions of the system are the overlapping shaded regions, all the points in the overlapping shaded regions. So let's go through a few examples and try those. So this first system, we're going to do just two examples here. Let's do this first one and this one down here. Okay, this first system, if you have an equation where it's y is less than 3, do you see how there's no x's there, which means there's no slope, which means it's a horizontal line, right? And then since it's less than or equal to, that means I have a solid line and I'm shading below. And what I'm going to do is I'm going to graph this up here. Right? So if I'm looking at this graph, I have a horizontal line that is solid. Oops. Right? So I have a horizontal line that is solid at a y value of 3. And I'm going to be shading below that line. So I've graphed one of my lines. And then the second one, since we have a greater than symbol, it's going to be a dotted line. And I'm going to have to shade up. So I'm going to use my y-intercept as my first point. And then it says I have a slope of -1. Oops. So I'm going to go down 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1. Connect those dots, right, for that blue line. And then it says I have to shade above the blue line. And then hopefully you guys can see where the blue and the pink are overlapping. What I like to do to make these questions easier to see that solution region is I really like to highlight and make darker that shaded region so it's easier to see. On a quiz or a test, I'm going to want to see an obvious overlapping region. So it might be a good idea just to make it darker than the rest. Okay. Looking at another example, so we're going to do this second one here. Y is greater than x minus 7, and then 3x plus 6y is less than or equal to 12. So for this first line, I have a greater than symbol, which means I'm going to have to shade above, and it's going to be dotted. So if I were to graph this line, I'm going to draw my coordinate axes. I have a y-intercept of -7, but a slope of 1. So I'm going to go up 1 over 1. Oops. This isn't exactly the straightest line in the world. Oops. Looks like I used the wrong color, so I'm going to use blue. Okay. So if we have a dotted line, and I'm going to have to shade above, right? Here is my region so far. And then it looks like for this next one, I have a little bit of extra work to do to solve for y. When I solve for y, my last step is dividing by 6. I get -1/2 x plus 2. So if I have a less than or equal to symbol, then that means I'm going to be a solid line, and I shade below. And if I have a y-intercept of 2, so I'm going to plot my y-intercept. Down 1 over 2, down 1 over 2, down 1 over 2, right? What I'm going to do is make my line solid, and I get to shade below the pink. And hopefully you guys can see that overlapping shaded region. Like I said, I like to make it dark and obvious, so that way whoever is grading my quiz or test can clearly see where my overlapping shaded region is. Right? Okay, so really essentially that's it, with the exception of some special cases. So if you take a look at these equations here, what you're going to notice, inequalities here, that they have the same slope and different y-intercepts, which means they're parallel lines. So you're going to notice something special is going to happen sometimes, and sometimes it won't. So what I'm going to do is I'm going to graph both of these lines. This first one, we should have a solid line, and you shade below. And then the second one, you're going to have a dotted line, and then you're going to shade up. Right? And if I were to draw this out, I'm going to have, for my blue line, I have a y-intercept of -4, and I can go down 2 over 1, or I guess I could go up 2 back 1 as well, right? And if I drew a solid line, right? I'm drawing a solid line, and I'm going to shade below that line, right? Here's my first shaded region. And then I get to graph my pink with a y-intercept of a +5, and then we can keep going down 2 over 1, down 2 over 1. Right? This time we have a dotted line, and it says we have to shade above the pink. And what you're going to notice is there is no overlapping region, which means no solution. Now, this isn't always going to be the case with parallel lines in inequalities, because couldn't we shade above the blue and then below the pink and then have an overlapping shaded region, right? So it is possible to get no solutions with parallel lines, but remember, it's not always no solutions with parallel lines. So I do need you to graph it out with these inequalities and check. Okay, one last thing I want to talk about with you guys is story problems. So let's talk about cheese, because everybody loves cheese. I like a good cheesy math joke too, so more than one type of cheese. But anyway, Alice is serving pepper jack cheese and cheddar cheese at a party. She wants to have at least 2 pounds of each. So you want to have, let's call pepper jack is X, and let's call cheddar cheese Y. So if you want at least 2 pounds of each, then that means X has to be greater than or equal to 2, and that means Y has to be greater than or equal to 2, right? That means you have to have at least 2 of both. Then she wants to spend at most $20 on cheese, and I see a cost per pound for these things. So if you want to spend at most $20, that means you have to stay less than or equal to 20. And then if it's $4 for pepper jack and $2 for cheddar, we have our inequalities here, right? So just to remind you guys, an X equation is vertical and a Y equation is horizontal. So if I were to try to graph my system of inequalities here, this one's kind of a tricky one, right? So if I have my X and my Y axis, so remember X is my pepper jack and Y is going to be my cheddar. That means that X has to be greater than or equal to 2, so I'm going to have a horizontal line, a vertical line at 2. And if X has to be greater than 2, think X is 3, 4, 5, that means I'm shading to the right. That's kind of a tricky concept. And then we have a Y is greater than or equal to 2. So I have a horizontal line that I'm also shading above. So right now we have a double overlapping shaded region, right? But we still have to graph our blue line, and to do that we need to solve for Y. And when I divide by 2, I'm going to get Y is less than or equal to negative 2x plus 10. Which means I have a y-intercept of 10, and I'm going to go down 2 and over 1. Down 2 over 1, down 2 over 1, right? Until I get my line. And then it says to shade below the blue, right? So what I see is right here is really the only section where all 3 of my lines were shaded. So it had to be to the right of 2, it had to be above 2, and it has to be below that blue line. And then any combination in this area would have worked. All right, get started on your homework, page 1 only.